In this video, we will look at several more examples of differentiating trigonometric functions and in turn finding the equation of a desired tangent line. So in this problem, we'd like to find the equation of the tangent line to the curve y equals sine x at x equals pi. So as a reminder, if we want to find the equation of this tangent line, since it's at x equals pi, if we let f of x be the function sine x, the form of the tangent line is going to be y is equal to f prime of pi, the slope of the tangent line, times x minus pi plus f of pi. So that is, it's the line with slope f prime pi, and it passes through the point pi comma f of pi. So we need to calculate a few quantities here. We need to know the slope of the tangent line, and we need to know the value of the function f at that point pi. So f of pi equals sine of pi, which is equal to 0. So the f of pi term is going to be a 0. We now need to determine the slope of the tangent line, f prime of pi. Well, the derivative of sine is cosine, and f prime of pi is cosine pi, which is the number minus 1. So that means that f prime of pi, the slope of the tangent line, is minus 1. So our tangent line is y equals minus 1 times x minus pi, which simplifies to y equals minus x plus pi. So let's look at one more example. Let's find the equation of the tangent line to the curve, now of the function sine squared x at x equals pi over 4. So for this problem, we're going to let f of x be the function sine squared of x. And if we want to find the tangent line at pi over 4, it will be given by y is f prime pi over 4 multiplied by x minus pi over 4 plus f of pi over 4. So the line with slope f prime pi over 4 going through the point pi over 4 comma f of pi over 4. So let's first take care of the function evaluation. F of pi over 4 is sine squared of pi over 4, which we can think of as being sine of pi over 4 squared. Sine of pi over 4 is a common value. It's 1 over the square root of 2, and when we square that, we get back 1/2. So f of pi over 4 is 1/2. Now we need to determine the derivative so that we can evaluate it at the desired point. So in terms of differentiating this function, it's sine squared. It is convenient to write that as sine multiplied by sine so that we can use the product rule. The product rule tells us the derivative of the first times the second plus the first times the derivative of the second. The derivative of sine is cosine, so we have cosine sine plus sine cosine, which is 2 sine cosine, because we have the same term added up twice, so there's 2 of them. And from the double angle formula, this is equivalent to sine of 2x. The number that we need is f prime of pi over 4. So this would be sine of 2 pi over 4, which is sine of pi over 2, which is equal to the number 1. It's a common value of sine. So f prime of pi over 4 is 1. So the equation of our tangent line is y is equal to 1 x minus pi over 4 plus 1/2, which is y equals x minus pi over 4 plus 1/2. So once again, an observation to make is before differentiating, it's oftentimes more efficient to rewrite the function algebraically. Here the observation is that sine squared is sine times sine, so that we can then apply the product rule.